So this is 2.1c, third video of 2.1, and one of the things I'd like you to realize here is what happens as angle A increases in size. So here's just a little guy, maybe say 20 degrees. Here it went to maybe 45, and here it went maybe to 60. What happened to the y value as the angle got bigger? Well, as the angle got bigger, the opposite side, y, got bigger. And what happened to x? As y got bigger, x got smaller. But what I'm really wanting to focus on is what happened to y, how much bigger it got. So as a increases from 0 degrees all the way up to 90 degrees, the length of the side adjacent to A, okay, so we started here, x, it gets smaller and smaller. So what happens is, if I were to be using my cosine of A, what happens is that is adjacent over hypotenuse, or x over r. R will never change. R stays the same, it's the radius, but x gets smaller and smaller. Well, what happens to a fraction as x gets smaller? Let's say we start out with 6 over 7, and we go to 5 over 7, and then 3 over 7, and then 1 over 7. What happens to the value? It gets smaller. So as the cosine of an angle gets larger, as the angle gets larger, the cosine gets smaller and smaller. The value of the cosine decreases as the angle changes from 0 to 90 degrees. A similar discussion happens when A increases from 0 to 90, and we're talking about what happens to the sine. So let's get rid of this stuff and just look at the sine. And the sine is the opposite over hypotenuse. So sine of A is opposite over hypotenuse, or y over r. Notice what happened here. As A gets bigger, as this angle gets bigger, what happens? My y value increases and my r value stays the same. So maybe for this one right here, my y value is 2 and my r value is 7. So let's make that a 2 and a 7. When I get to this one, my r value is still 7, but maybe my y changes to 5. So what happens as my angle gets bigger in my sine, the ratio gets closer and closer and closer to 1. So maybe this angle over here is 6 over 7. Maybe this length is 6 now over 7, until it actually becomes 1 at a 90-degree angle, because pretty soon this thing will get so big that this line and this line will become the same line and equal 1, because any number over itself is going to be 1. Which brings us to example 4. Which one of these will give us the bigger number? Sine of 21 or sine of 18? Or in other words, what they have here is that a true statement? Yes, it is, because as the angle gets bigger, the sine of the angle gets bigger. So because this is the sine of 18 and this is the sine of 21, as the angle gets bigger in sine, because the opposite, this one, the opposite gets bigger, so therefore the sine of 21 is going to give us a bigger number than the sine of 18. But if we did the cosine of 21, and I said that was bigger than the cosine of 18, you'd find out that that is not a true statement, because as the angle increases with cosine, the cosine decreases. So I hope that makes sense, because remember, we're dealing with the x value, and see how the x is getting smaller, and x is the number that goes on top. So as the x decreases, the fraction, the cosine of 21, which is what this is if you were to divide x over r, that would get smaller. All right, we're going to look at trigonometric function values of special angles. Okay, so we have an equilateral triangle here at the top, which means that all the lengths of the sides are the same. So notice the lengths of the sides are 2, 2, and 2, and the angles are all 60s. And what we're going to do is we're going to cut that angle, or that triangle, in half into two angles. And we have two 30, 60, 90 angles. Okay, now notice what happened. Our hypotenuse stayed 2. This, which was 2 up here, changed to 1 because we cut it in half, right down the middle. And this is a 90-degree angle. So we cut it right down the middle. And we don't know, let me get my pointer, we don't know the length of this, so we called it x. And now in order to find out what this x value is, we just use Pythagorean. And so we take 1 squared, if I can get my pen working, which is this, plus x squared, which is what we're looking for, equals 2 squared, which is my hypotenuse. So 1 plus x squared equals 4, x squared equals 3, x equals the square root of 3. So that ends up being the height there. And so now we have a special triangle called a 30, 60, 90 triangle. And this is the ratio between the sides of that triangle. 1, 2, and the square root of 3. Always will be there, always will work, and will always be a part of doing a lot of these solutions you're going to be doing over the next few weeks. So remember the sides of that, 1, 2, and square root of 3. And what that does is it gives you an easy way to find out the trig functions of this 30, 60, 90 triangle. So let's get rid of my blue ink here. And we're going to take this drawing and we're going to see if I can flip it. Maybe I can't. Maybe I can. Okay, and let's kind of move it over here. And let's say that we're interested in finding out the trig functions of this. So if we want to find out what the sine of 30 degrees is, which is this one right there, we just do opposite over hypotenuse, which is 1 over 2. So the sine of any 30-degree angle is 1/2. The cosine of a 30-degree angle is adjacent over hypotenuse, which is going to be square root of 3 over 2. The tangent of a 30-degree angle is going to be opposite over adjacent, which in this case is going to be 1 over the square root of 3, and then you have to multiply it by the square root of 3 over the square root of 3 and get square root of 3 over 3. So you get that. And you do the cosine, or the cosecant, secant, and cotangent. I feel sorry for those last three because they kind of get left out, but you know what I mean. You just flip them over in order to find those. If I was interested in the sine of a 60-degree angle, which would be this one here, it would be, again, opposite over hypotenuse, which in this case, the opposite of the 60 is the square root of 3 over 2. The cosine of that 60-degree angle is going to be adjacent over the hypotenuse, and the tangent of that 60-degree angle is going to be opposite over adjacent. Now notice, again, our cofunctions. Cosine of 60 is 1/2, sine of 30 is 1/2. So 30 and 60 add up to be 90, and we know sine and cosine are cofunctions of each other. So that is one of the special angles that we're going to look at. Yeah, they do give us the other special angle, and we'll do that in the next video.